Hello learners, I welcome you all to the online course on domestic equipment maintenance. I am Dr. Antara Mohanto Borua, Assistant Professor in the discipline of Electronics, Krishnakanta Handik State Open University, Guwahati, Assam. So learners, in this session we are going to discuss about the electrical energy and its conversion from one form of energy to another. It is the second lecture of the first module on electricity and safety measures. In the previous lecture, we have discussed on the topic understanding electricity. In today's topic, we will focus on basic concept of energy, various forms of energy, advantages of electrical energy, energy conversion methods, types of electric motors, and challenges associated with the conversion of energy. Now let us come to the learning objectives. The main objectives of this session are to provide the basic concept of energy and its various forms, to discuss the advantages of electric energy, then to familiarize with the energy conversion processes, then to identify the different types of electric motors, next to get an idea of the challenges of conversion of energy. Now let us first discuss the basic concept of energy. All the living beings need food to survive, and for this they have to perform several activities. For these activities, energy is needed, which comes from food. The first source of energy is the sun, which gives heat and light during daytime. After the discovery of fire by the ancestor of humans, they learned how to cook and eat. Early humans were using fire in many aspects of daily life, such as cooking, hunting, and making tools. After that, when humans started cultivation, they require animals and machineries to help them for agriculture purpose. And that is the way the energy requirements started and increasing day by day. Energy is the fundamental concept in physics, and it is defined as the ability to do work. In simpler terms, energy is the capacity of an object or a system to perform a physical action. Work is defined as the transfer of energy. This occurs when a force is applied to an object and causing it to move in the direction of the force. Work is directly related to the displacement of an object and the force applied to it. Work is calculated using the formula W equal to F into D into cos theta, where W is the work done, F is the magnitude of the applied force, D is the displacement of the object, and theta is the angle between the force vector and the displacement vector. As energy is equivalent to the amount of work done, so the unit of energy is same to that of the work. The SI unit of energy is joule and the commercial unit of energy is kilowatt hour. 1 joule of work is defined as the amount of work done by a force of 1 Newton applied to an object, and the object is displaced by 1 meter in the direction of the force. When magnitude of force is 1 Newton, displacement is 1 meter, and the angle between force and displacement vector is 0 degree, that is cos 0 degree equal to 1, then using the formula, the work done would be 1 joule. So 1 joule of work is equivalent to exerting a force on 1 Newton over a displacement of 1 meter in the direction of the force. Now power. What is power? Power is defined as the rate of energy use. In terms of electricity, power is equal to current into voltage, or watt equal to amperes into volt, as discussed in the previous lecture. And energy is equal to power into time. Higher power means energy is consumed and transferred at a faster rate. To best understand this, let us consider a case. A 100-watt bulb that is turned on for 1 hour. The power rating of the bulb is given as 100 watts, which means it consumes 100 joules of energy per second. The time for which the light bulb is on is 1 hour, which is equivalent to 3600 seconds. Using this equation, we can calculate the energy consumed by the bulb. As energy equal to power into time, energy is equal to 100 watt into 3600 seconds, then energy is equal to 360,000 joules or 360 kilojoules. So in this example, the bulb consumed a total energy of 360 kilojoule over the 1 hour period. So this is the way the work, power and energy can be related. Now we shall discuss the forms of energy. Energy can exist in many different forms. The two major types of energy are potential energy and kinetic energy. Potential energy is the energy that is stored in an object due to its position or configuration. For example, a ball held above the ground has potential energy because it can fall and do work when released. Different types of potential energy are gravitational potential energy, mechanical potential energy, chemical potential energy, and nuclear potential energy. The energy stored in an object due to its height relative to the Earth's surface is called gravitational energy. That means the higher and heavier the object, the more gravitational energy is stored. Example of gravitational energy is hydroelectric power plant, where the force of flowing water turns the turbines to produce electricity. Now, mechanical energy, also known as elastic potential energy. Energy is stored in an object when it is stressed or compressed. Examples are compressed spring and stretched rubber band. Next, chemical potential energy. It is the energy stored in the bonds of atoms and molecules within chemical substances. An example of chemical energy is the operation of an internal combustion engine in a car. Internal combustion engines convert the chemical energy stored in fossil fuels such as gasoline or diesel into mechanical energy to drive the vehicle. Next, nuclear potential energy. It is the energy used in the nucleus of an atom. It releases from the strong nuclear force, which is the attractive force that holds protons and neutrons together in the nucleus. A large amount of nuclear energy is released during nuclear reactions such as nuclear fission, that means splitting of atomic nuclei, or nuclear fusion, that is combining of atomic nuclei. An example of nuclear energy is the energy produced by the sun. The sun produces its energy through a process called nuclear fusion, where hydrogen nuclei combine to form helium nuclei, releasing a large amount of energy in the process. Now, let us discuss the kinetic energy. Kinetic energy is the energy of motion, and it depends on the mass and velocity of an object. The faster an object moves, the more kinetic energy it has. Different types of kinetic energy are thermal energy, electrical energy, light energy, sound energy, motion energy, etc. Now first we will discuss the thermal energy. This is the energy associated with the temperature of an object. It is the sum of the kinetic energy of the individual particles, that is the atoms or molecules within an object. It increases when atoms and molecules moves faster and collide with each other. Example is geothermal energy. Next, electrical energy. Electrical energy is the energy associated with the flow of electric charges called electrons. It can be generated by chemical reactions, electromagnetic induction, or other processes. It can be found in batteries, power lines, and electrical circuits. Example, the natural electrical energy is the lighting process. Next, light or radiant energy. Light energy refers to the energy carried by electromagnetic waves. It includes visible light, ultraviolet radiation, and infrared radiation. Some examples of light energy are lamps, street light, headlights, and display screens. Now, sound energy. Sound energy is produced by vibration that propagates as wave through a medium such as air or water. Example is the musical instruments or sound system. Now, motion energy. It is the energy stored in the movement of objects. The amount of motion energy an object has depends on its mass and velocity. The faster they move, more energy is stored. Example is the wind. These are some of the major forms of energy. Now let us discuss the advantages of electrical energy. Electrical energy can be converted into other forms of energy like mechanical, thermal, etc. easily. Electric energy is unrivaled for many uses such as lighting, cooking, computer operation, traction, industrial heating applications, entertainment applications, etc. The use of electrical energy is pollution-free. Electrical energy is considered more advantageous than other forms of energy. The main advantages of electrical energy are: the conversion of electrical energy into other forms of energy is easy. It can be transmitted from one place to other place easily. The transmission efficiency is high. The operation and control of electrical machine are simple and easy. Electrical energy is cheaper than other forms of energy. It is neat and clean and free from smoke and fumes or poisonous gases. Dear learners, let us do a self-check of our learning so far by attempting the questions shown in the screen. After attempting these quiz questions, we now go ahead to the next topic about the energy conversion methods. Now let us discuss energy conversion methods. Energy can often be converted from one form to another. It is conserved in all physical systems, which means that the energy cannot be created or destroyed, only transformed from one form to another. This principle is known as the law of conservation of energy. So, the principle of conservation of energy states that energy cannot be created or destroyed, but it can be transformed from one form to another. For example, when a ball is thrown upward, its kinetic energy is transformed into potential energy as it rises up, and then back into kinetic energy as it falls. Conversion of energy from one form to another takes place through various processes. One of the common forms of energy conversion is the conversion of mechanical energy into electrical energy. This is typically done using electric generators. So, electric generator is a device which converts mechanical energy into electrical energy. It uses a rotating shaft to turn a coil of wire inside a magnetic field. Copper conductors in the form of coil of large numbers of turns called winding are placed in slots in a cylindrical rotor called armature. The magnetic field surrounds the armature. As the coil turns, it generates electrical energy which can then be used to power a variety of devices. Electrical to mechanical conversion. An electrical motor converts electrical energy into mechanical energy. It is an electromechanical device. Conversion of electrical energy to mechanical energy is a critical process that powers a large number of machines and devices that are essential for modern life. Now, principle of electrical energy conversion to mechanical energy. Electrical energy conversion to mechanical energy occurs when an electric current passes through a conductor in a magnetic field. This process is based on the principle of electromagnetic induction. In 1831, a famous English scientist named Michael Faraday explained that a magnetic field can create an electric field in a conductor. This phenomenon of producing electricity from magnetism is called electromagnetism. When the magnetic flux linked with a conductor changes, an electromotive force is generated in the conductor. This phenomenon is known as electromagnetic induction. In other words, the generation of electromotive force in a conductor due to the change in magnetic flux linked with the conductor is known as electromagnetic induction. The electromotive force developed in this process is induced EMF, and the corresponding current through the conductor is called the induced current. The conversion of electrical energy to the mechanical energy occurs in the stator and rotor of the electric motor. As shown in the figure, the stator is the stationary part of the motor, which contains the electromagnets that generates the magnetic field. The rotor is rotating part of the motor, which is connected to the shaft and rotates when the motor is energized. When an electric current is applied to the stator, it generates a magnetic field that interacts with the magnetic field of the rotor. This interaction causes the rotor to rotate, generating mechanical energy. Now, types of electric motors. The electric motors can be classified as DC motor and AC motor. However, there are motors that run on both AC and DC. AC motors are further classified as single-phase AC motor and three-phase AC motor. Now let us see what is DC motors. DC motors are the simplest and most common type of electric motor. The essential parts of a DC motor are poles, armature core, armature winding, commutator, and brush. They work by passing a direct current through a stator, which generates a magnetic field. The magnetic field interacts with the magnetic field of the rotor, causing it to rotate. DC motors are widely used in industrial machineries, electric vehicles, and home appliances. They are efficient, reliable, and provide a good speed control. AC motors. AC motors are another common type of electric motor. There are several types of AC motor. Single-phase induction AC motor are very common in domestic appliances. The essential parts of AC motors are stator and rotor. They work by passing an alternating current through the stator, which generates a rotating magnetic field. The magnetic field interacts with the magnetic field of the rotor, causing it to rotate. AC motors are widely used in industrial machineries, home appliances, and electric vehicles. They are efficient and provide good speed control. Next, stepper motors. Stepper motors are a type of electric motor that provides precise control over the rotating of the rotor. They work by applying a sequence of electrical pulses to the stator, which causes the rotor to rotate in precise increments. Stepper motors are widely used in robotics, automatic, and precision control systems. They provide accurate positioning and speed control, making them ideal for applications that require precise movement. Now let us discuss the applications of electrical energy conversion to mechanical energy. The conversion of electrical energy to the mechanical energy has many applications in various fields. Some of the common applications are industrial machineries. Electric motors are widely used in industrial machineries such as pumps, compressor, and conveyor systems. They provide efficient and reliable power in these machines, allowing them to perform their functions with precision and speed. Next is electric vehicles. Electric vehicles used electric motors to convert electrical energy into mechanical energy to power their wheels. They are becoming increasingly popular due to their energy efficiency and environmental benefits. Home appliances. Electric motors are very common in home appliances. Some of the common and popular household appliances whose working depends on electric motor are fan, mixer, grinder, hair dryer, refrigerator, washing machine, vacuum cleaner, etc. Electric motor provides efficient and reliable power to these appliances, making them more energy efficient and cost effective. Robotics and automation. Electric motors such as stepper motors are widely used in robotics and automation. They provide precise movement control, allowing robots to perform complex tasks with accuracy and repeatedly. Now let us discuss the motors in domestic appliances. Most of the domestic appliances are designed to work with AC 220 volts 50 Hz power supply. So, single-phase AC motors are very common in domestic appliances. Low-power appliances that operate in DC supply have DC motors that commonly run on 9-volt DC or 12-volt DC obtained from battery or common voltage adapters. There are some motors that run on DC voltage of 1.5 volts or 3 volts of battery, and these are often used in low power gadgets, toys, etc. Thermal energy into mechanical energy. Another common forms of energy conversion is the conversion of thermal energy into mechanical energy. This is typically done using heat engines. Heat engines uses a fuel source to generate heat, which is then used to produce mechanical work. The most common example of a heat engine is the internal combustion engine used in cars and other vehicles. In this type of engine, fuel is burned inside a combustion chamber to produce heat that is used to power a piston. A piston is then used to turn a crankshaft, which generates mechanical energy that is used to move the vehicle. Chemical energy to thermal energy conversion. By using combustion processes, chemical energy can be converted into thermal energy. Combustion processes such as burning fossil fuels or wood convert the chemical energy stored in these substances into thermal energy. The heat released during combustion can be used for heating, cooking, or generating steam for power generation. Electrical energy to thermal energy conversion. Electricity and thermal energy are two forms of energy that are vital to our daily lives. Electrical energy is the energy that is carried by an electric current, which is the movement of electrons through a conductor. This energy is typically generated by power plants, which convert other forms of energy such as mechanical or chemical energy into electrical energy. Thermal energy, on the other hand, is the energy that is associated with the movement of atoms and molecules within a substance. This energy is typically measured in terms of temperature, and it can be transferred from one object to another through conduction, convection, or radiation. Thermal energy is used for a wide range of applications such as heating and cooling, cooking, and industrial processes. Now, methods of converting electrical energy to thermal energy. There are the several methods that can be used to convert electrical energy into thermal energy, each with its own advantages and disadvantages. Here are some of the most common methods. Resistance heating. Resistance heating is the simplest and most common method of converting electrical energy to thermal energy. It involves passing an electric current through a resistor which converts electrical energy into heat. The amount of heat produced by resistance heating can be calculated using this formula: Q equal to I square into R into T, which states that the heat generated is equal to the product of the square of the current and resistance and the time. This is known as Joule's law. The higher the resistance and voltage, the more heat is produced. This method is used in a wide range of applications such as heating elements in ovens and toasters and electric space heaters. However, this method is not very efficient as a lot of electrical energy is lost as heat in the wiring and other components of the system. Next, induction heating. Induction heating is a method that uses an alternating magnetic field to generate heat in the conductive material. This method is used in industrial applications such as heating metals for welding and melting metals for casting. In induction heating, an alternating current is passed through a coil of wire which creates a magnetic field. The magnetic field lines passing through the material generate electric currents within it. These electric currents are called eddy currents. The eddy currents flowing in a conductive material encounter resistance, and this resistance causes the conversion of electrical energy into heat. The efficiency of induction heating depends on the frequency and intensity of the magnetic field, the properties of the material being heated, and the design of the heating coil. Now, microwave heating. Microwave heating is a method that uses electromagnetic radiation at the microwave frequencies to heat a material. This method is commonly used in cooking appliances such as microwave ovens. Next is the heating effect of electricity. The heating effect of electricity, also known as Joule heating. It is a phenomenon in which the electric current passing through a conductor to produce heat. When an electric current flows through a conductor such as wire or heating element, the resistance of the material causes the electrons to collide with the atoms in the material. This collision produces heat energy, which causes the temperature of the material to increase. This phenomenon is used in a wide range of kitchen appliances. The amount of heat produced by the electrical current depends on several factors, including the resistance of the material, the current flow, and the time the current flows through the material. Now, electric appliances using heating effect. Most common electric appliances that use the heating effect of electricity are electric kettle. Electric kettles are one of the most common household appliances that use the heating effect of electricity. Electric oven. Electric ovens are another common appliance that uses the heating effect of electricity. Next, electric stove tops. Electric stovetops are a popular alternative to gas stovetops and used in heating effect of electricity to cook food. Then electric space heaters. Electric space heaters are a convenient way to heat a room using the heating effect of electricity to produce heat. These are some examples of energy conversion processes commonly used in various applications. Energy conversion occurs in different forms depending on the specific needs and technologies involved, and they play a crucial role in meeting the energy requirements and powering various systems and devices. So learners, as we have come to the end of the discussion on energy conversion methods and types of electric motors, let us test our learning by attempting the given questions. After attempting these multiple choice questions, we now go ahead to the last topic about the challenges of energy conversion. Now the last topic is the challenges of energy conversion. One of the biggest challenges associated with the energy conversion is the need to minimize energy losses. Whenever energy is converted from one form to another, some energy is lost in the process. This is due to the factors such as friction, heat loss, and electrical resistance. For example, when electricity is transmitted over a long distance, some energy is lost due to the resistance of the transmission lines. In order to minimize these losses, it is important to develop more efficient energy conversion technologies, as well as better methods for transmitting and storing energy. Another challenge associated with energy conversion is the need to develop more sustainable and environmentally friendly energy sources. Many of the energy sources that are used today, such as fossil fuels, have significant environmental impacts. In order to mitigate these impacts, there is a growing need to shift towards renewable energy sources such as wind, solar, hydropower, etc. However, these energy sources also present their own unique challenges such as the intermittency of wind and solar power and the need to develop new storage technologies. In conclusion, energy conversion is a critical process associated with a number of challenges. As we continue to face these challenges, there will be a growing need to develop new technologies and strategies that can help us to more efficiently and sustainably convert energy from one form to another. So learners, in today's session, we have discussed about the concept of energy, then various forms of energy such as chemical energy, mechanical energy, electrical energy, thermal energy, etc. Then we have discussed how to convert the energy from one form to another and how to utilize the energy in different ways in our daily life. Then we have learned different types of electric motors. At the end, we have discussed the challenges associated with the energy conversion process. In the next session, we will focus on the basic safety practice. I hope the information given in this video would help you to enhance your knowledge about the concept of energy. Thank you.